Hi everyone, this is Dr. Heather Austin Robillard again, and today's lecture is going to be about reliability and validity, which is important for determining and picking a good test or measurement tool. What we will be focusing on when it comes to the ICRC licensing exam for an LCDC would be the task and knowledge of administration and scoring procedures for substance use disorder instruments, the selecting and administering of assessment instruments, and the knowledge of appropriate screening and assessment tools. Basically, the question we'll be asking is, how do I know that my tests are good tests? This is reliability and validity in a nutshell. Reliability is recognizing whether your test is consistent, and validity is, does your test really measure what you're saying it measures? So if we look at the first target area, all of the points are in one area, which tells us that it is consistent, it's reliable, but it's not hitting the center, which is where we want it to hit, so it's not actually valid, it's not measuring what we want it to. Then if we look at the second bullseye, we show that this is low validity and low reliability. So it's not really hitting our target, so it's not measuring what we want it to measure, but it's also kind of all over the place, so it's not really consistent. And then if we look at the third target area, we show that it's not reliable and it's not valid. So it is completely not close to the target, and it's not really consistent, and it's not consistent, so it's not valid. And then the last one shows us what reliable and valid would look like. It's all kind of close together in the center, exactly where we're trying to hit. So then the next question is, how do I evaluate the goodness of a test? Well, one way to do this is called a correlation analysis. So first we need to learn about what is a Pearson correlation coefficient, or the little r. Correlation analysis is basically the measurement of the degree of a linear relationship. So more appropriately, this basically means the association or the relationship between constructs or across items. So remember, a construct, test, or item is associated or related to another construct, test, or item. For example, is the amount of time watching TV related or associated with the number of friends that you have? We're trying to recognize the relationship. In order to do this, these are the questions that we're trying to answer with a correlation analysis. Is there a significant relationship between variables? We also want to know the direction of that relationship. Is it a positive relationship, a negative relationship, or is the relationship zero? And then the strength or the magnitude of the relationship between these two variables. So first, let's talk about the direction of the relationship. So this may be confusing because it says positive or negative, and sometimes we think of that in certain terms. But in regards to correlation, a positive relationship is when one variable goes up, the other predictably also goes up. In a negative relationship, it's the opposite. When one variable goes up, the other goes down. And then zero is no linear relationship. Curvilinear would be the relationship is not covered by Pearson's correlation. And now we step into the magnitude or the strength of this relationship. The strength of the relationship is measured by a statistic called the correlation coefficient. This varies from 0 to +1 and from 0 to -1. A perfect +1 is a perfect positive relationship. A perfect -1 is a perfect negative relationship. As you can see in the scatter plots shown above, it shows how the dots and the observations cluster together. So a weak correlation shows all of the dots a little bit more spread out, but kind of going in a similar direction. So when we're measuring the correlation coefficient, we're looking from anywhere between 0 and -1 or +1. And so anything above 0.6, either negative or positive, is usually a strong relationship, strong strength of the relationship. And anything above 0.3 to 0.6 would be about a moderate. So that would be okay as well, but likely we would want as high as we can go. So in summary, sometimes you will see this little asterisk and it'll say something like P is greater than, or it'll say something like P is less than 0.05. This just means that the correlation was found just by chance or not. But we won't really talk much about that in this discussion. So in direction, if it's positive, one variable goes up and the other goes up. It can also be one variable goes down and the other goes down as well, as long as the relationship is the same. But if it's a negative relationship, they're going the opposite direction. So one variable goes up and the other one goes down, or one goes up, down and one goes up. It's always the opposite. Magnitude measures how strongly associated the two variables are, how close that they are. So 0.3 is weak, 0.3 to 0.6 is moderate, 0.6 to 0.99 is a strong correlation, and 1 is a perfect correlation. So you may be asking yourself, why do I need to know this? Well, it's important because we are going to look at relationships. We're looking at relationships between variables, whether they have a substance disorder and, how many negative withdrawal experiences they have. We're also looking at between tests. So maybe we're looking at the audit compared to the SASE. We're also going to be looking at between items within your test. So different questions between those. So let's talk about reliability in relation to this. And remember, reliability is testing whether your test is stable and consistent. And so we want it to look like the far left one, both reliable and valid. So there is a way to kind of look at this differently. Let's compare a ruler made by hard plastic versus one that's made by clay. With the clay rule, will the clay ruler be reliable? Will it stand over time? And will the measurement be the same over time? Each inch will be the same across the entire ruler. Likely not, right? So why might a test be unreliable? Usually that's because of error, test administration error, test scoring error, item selection, systematic measurement error, or maybe just random error. This can cause a test to not be reliable. Then we also have temporal stability and test-retest reliability. So is my instrument consistent over time? The test instrument over periods of time, we would use a test-retest reliability and a coefficient of stability. Test-retest reliability is showing the reliability over time. It is used on like a trait, rarely on a state. So the correlation is between test 1 and then test 2, which takes place at another time. Test of stability is more than 6 months. Is the variable stable over time? Is the test stable over long periods of time? And then again, it's very similar in the coefficient. 9.9 is high, 0.8 is medium, 0.7 is low, 0.6 is very low, and 0.95 is very high. Then there's internal consistency tests. Is my instrument consistent with itself? Is one half of my instrument consistent with the other half? So this is like split half reliability. Are the items in my instrument consistent with each other? Imagine a hard ruler cut in half. If the first half measures 3.5 inches, will the second half measure 3.5 inches? And are all the inches measuring the same? In order to measure internal consistency, we would do split half reliability test. We split the test into two and correlate one half with the other to look for consistency between parts. We may do odd or even numbers or divide by topic and difficulty. And again, passing is 0.7 or higher. Above 0.9 is redundancy, and below 0.7 is unreliable. So if we get a correlation of above 0.9, basically our items or that half of the test or whatever is kind of measuring too similarly, so it's telling us it's redundant. Whereas if it's 0.7 or below, then it's telling us our test is not reliable between items or being split in half. We would also use the Cronbach's alpha. This is a mean of all possible split half correlations, so consistency among items. This is the preferred statistic in internal consistency, and it works the same way as the previous slide. There's also parallel or alternate reliability, comparing my test with other forms of the test, so maybe different editions or other tests that are measuring similar types of constructs. And then there's inter-rater reliability. This is if people are the instruments, see if their scores are consistent with each other. This is, for example, if you are scoring based off of observations. If I'm a researcher and then Paul's a researcher and we're both looking at an observation and making our scores based off of the observation, are our scores similar? Do they correlate? Now let's talk about validity. And remember, validity is measuring, does your test measure what it says it's measuring? So if I'm trying to measure substance use disorders, is my test actually answering that question, or is it answering other questions? And so remember, we want it to be measuring or hitting that target. Now there's a couple different kinds of validity. Face validity is, does it look like it measures your variable? You can ask yourself, you can ask others, and you can ask experts to see if the questions or items on the measurement are looking like they measure the specific variable you're wanting to measure. Then there's criterion-related validity. Is it functioning the way it's supposed to? Can it predict the future behavior of a person? Then there's construct validity. Is it like similar constructs and variables? Is it different from opposite constructs or variables? In order to measure this, we would do something like a factor analysis. We're looking at the developmental changes, maybe evidence from distinct groups, convergent evidence, discriminant evidence, and evidence from pre-test and post-test changes. Convergent and discriminant evidence is, does construct A is construct A answered in test A? And is construct B answered in test B? Then we're looking at the difference between construct A and construct B, as well as, does construct A have a relationship with test B? And what is the relationship between test A and test B? When evidence comes together to prove that the test measures what it intends to measure, we're looking at other tests versus other measures, or same constructs versus like constructs. We're comparing it to what it is not, proving that the constructs that are not related are not significant or have little relationship. And we're proving that the opposite constructs are negatively correlated to show that it's actually measuring its opposite. Then we're looking for evidences of change with age and time. If theory says that there should be a change with age or time, the developer should establish such. So maybe a longitudinal study or a within sample statistic. So looking at comparisons between age within that study. Pre-test and post-test is if the theory says that there will be a change in the construct over time or because of an event, the developer needs to prove it. This can be experimental, it can be therapy, or maybe a loss of something. But we want to measure before this event happens and measure after the event happens to show that this theory and construct is proven correct. Then we also want to look at evidence from distinct groups. If the theory says that there are significant differences between groups, the developer needs to prove it. For example, if the construct is different between genders, we need to show that in a study, or is the statistic independent from groups? That ends this lecture slide. I hope you understand more of what it takes to choose a good test. And basically that it means we need to choose a test that is reliable and valid.